Hi, I'm Dion from leavingcertmathsvideos.com. Here you're told that you have 12 people in total and you have a team of 4 and you're asked to find how many different selections are possible. Well, that's the same as saying 12C4 because that's the way of writing it really. You're asked if I have 12 people in total, how many different groups of 4 can I pick from that? So that's equal to 12 times 11 times 10 times 9 all over 4 by 3 by 2 by 1. Which is, you can just do it in your calculator. 12C4 is equal to 495. Now, on the second part of the question, you're asked to find out how many of these have at least one girl. Well, basically, if there's 495 choices in total, and all you have to do is subtract the amount of options you have for teams containing boys. Like say if I was to tell you there was 10 teams possible if you were only to include the boys, well then the amount of teams with at least one girl would be 495 times 10. So I'll just go through this now. You've got 5 boys, so how many teams are possible with 4 people of 5 boys is there? Well that's equal to 5C4. Right, so you have 4 boys and you have 5 places in total for, sorry, 5 boys in 4 places in total. That's 5C4. 5C4 equals, that's equal to 5. So then you're told, out of all that combination, there's only 5 teams that can have boys. So if there's only 5 teams that can have boys and there's 490 possible teams in total, then there's only 490 teams left. 90 teams that have at least one girl in it. So that's 490 teams. So you've got 495 teams altogether. Only 5 of them teams are all boys. So the teams that aren't all boys have to have at least one girl. So 495 minus 5, which is equal to 490. So on to the second part of this question here. I wrote down the 0.5s here because, well, they're the odds and it'll just take me forever to do it in the video. So the first part of the question is, one of the paths from A to H is A, B, D, H. List the other 2 possible paths from A to H. Okay, so from A to H, but we're told A, B, D, H. What are 2 other possible paths? So it's A, B, E, H is one. That's one possible path, because we've done this one here. Now we have A, B, E, H is another one, and our other possible path is A, C, E, H. Very easy question for leaving cert maths. So that's your 2 options there. I'm just going to wipe it out because I want to keep this on the board here. Right now, the next question is, find the probability the marrow passes through H or J. So the probability to pass through H or J. Well, what I really did here is, I said, the probability of passing through H or J is 1 minus the probability that it passes through G or K. So I'll just write that down here. It's 1 minus the probability of the ball passing through G or K. So basically, if it passes through G or K, it doesn't pass through H or J. So if we calculate the probability of going through this one or this one, it's the exact same. If we subtract that from 1, it's the exact same calculating probability that goes through H or J. So, to work out the probability of passing through G or K, well, the probability of K and G are the exact same because it's symmetrical. So we just work out the probability of calculating through G, of going through G. So that's 0.5 times 0.5 times 0.5. So it's 0.5 cubed. So that's the probability of passing through G. The probability of passing through K is going to be 0.5 cubed as well. So basically we're going to say it's 2 times 0.5 cubed. So it's 1 minus 2 times 0.5 cubed. So I'll just work that out. 0.5 cubed is a half times a half, which is a quarter times a half, which is an eighth. Double an eighth is a quarter. Equals 0.75. So I'll just double check that. Yeah, 75%. So 75% chance that it'll pass through H or J, and then there's a 25% chance that it'll pass through K or G. So you could use that for the next part of the question if you wanted. I'm just going to wipe this out so I don't keep the same thing in the board. Right, and the next part of the question is, you're asked to find the probability that the marble lands at M here. Right, well, you could say that that's 1 minus the probability that the marble lands in G, plus the marble lands in K, or the marble goes from H to M, or K to P, or sorry, J to P. But we won't do it that way. We'll calculate all its different routes. So you have, the different routes are A, B, G, H, N, A, B, E, H, N. Then you have, sorry, A, B, E, H, N. Then you have A, C, E, H, N. And then you have A, C, E, J, N. Sorry for the bad writing here. So we have all these little A, C, E, J, N. So now what's left is A, C, F, J, N. So just check, I'll just go through these again. A, B, G, H, N. That's one of them. A, B, E, H, N. A, B, E, H, N. Always try to stick to the left and kind of work your way rightwards. So start off with B and then go left there and left again, because otherwise you get muddled up and you probably include something twice. So A, B, G, H, N, yeah. A, B, E, H, N, yeah. A, C, E, H, N, yeah. A, C, E, J, N, yeah. And A, C, F, J, N, yeah. So that's 5 different options. So, really what we have here is A, B, G, H, N. We have from A to B, the chances of going to B are 0.5. So it's 0.5 times the D is 0.5, times the H is 0.5, times N is 0.5. So that's 0.5 to the power of 4. Equal to 0.5 all to the power of 4. And this is also equal to 0.5 all to the power of 4, because it's 0.5 each time. So it's basically 0.5 to the power of 4 equal to 0.0625, and divide that by 5 is equal to 0.3125, or 31.25%. So that is the probability of that lands on M. So for the next part of the question, we're asked, 2 marbles fall from A, one after the other, affect each other. Find the probability of that they both land on P. Right, so we're going to do the same thing here, but the probability of it landing on P. So we just draw out the route map here for P. We start off at the right hand side this time. So we have A, C, F, K, P. A, C, F, K, P. Then we have A, C, F, J, P. And then we have A, C, E, J, P. And then we have A, B, E, J, P. P, so we have 1, 2, 3, and 4 different ways, yeah. So the probability of this going to this is, well, A is already like certain. So probably going to C is 0.5, so that's equal to 0.5 to the power of 4, and they're all going to equal the same, 0.5 to the power of 4. So the probability of it going to that is 0.5 to the power of 4 is equal to 0.0625, but you times that by 4 because you have 4 options. So the probability of the first ball lands in P is equal to 0.25. And then the probability of the second ball landing in P. So basically what you're asked to do here is to find the probability of the first ball landing in P and the probability of the second ball landing in P. So you know you have to add them here, or you have to multiply them. So it's basically a quarter times a quarter, which is equal to 1 over 16. Or write that in decimal form, I'm not sure if you ask for decimal form, 0.0625. Okay, and that's the end of that. So if you found this video useful, please add me on Facebook or Twitter, or subscribe to my YouTube channel, where I'm eventually going to have the last 6 years of honours maths video solutions up. Alright, thank you.